Okay, so I'm going to, well, I know I've gone live now, but I'm actually going to start in 4 minutes' time. And I'm planning on going over 12 topics that I think are likely to come up on the paper too. So I'm just going to spend a minute or two getting my focus sorted and everything. And then I'll properly go live at 5 o'clock. So what I'm planning on doing, I'm going to go over. So what I'm planning on doing, I'm going to go over. So what I'm planning on doing, I'm going to go over. So what I'm planning on doing, I'm going to go over. So what I'm planning on doing, I'm going to go over. I don't switch off the sound on this one. So I'm planning on going over 12 topics that I think are quite likely to come up. So they're going to be, I'm going to start off with the recurring decimals to fractions. So I'll start that in a couple of minutes' time. So I'm going to do recurring decimals to fractions, then have a look at bounds, then completing the square, then direct and indirect proportion, then a bit of a look at sequences, then some quadratic graphs, then simultaneous equations, both linear and quadratic, then angles on parallel lines, and then finally some histograms. So that's the plan. If any questions do crop up, then I'll aim to perhaps just do those at the end. So I'm just going to really keep the starts to going over the 12 topics. So it's 2 minutes to 5. So I'm going to properly start at 5. So I'm planning on going over 12 topics that I think are likely to come up for the paper 2 and the IGCSE higher, given that they didn't crop up in the first paper last week. If you've got any questions, then I'm happy to take any questions at the end of it. Okay, I think we're pretty much 5 o'clock now. So I'm going to start off with this one here, which I think is quite likely to come up, which is use algebra to show that the recurring decimal 0.3454545 is 19/55. So to do this, start off by letting x equal the recurring decimal. So that's a 0.3454545 and so on. Okay, the 2 dots are over the bit that are recurring. Now, because we've got the 2 dots, we're going to choose to multiply by 100. So 2 dots multiplied by 100, which has got 2 noughts. Had it been 1 dot, then you'd multiply by 10. So we're going to choose to multiply both sides by 100 for reasons you see why in a minute. So if we multiply both sides by 100, we get 100x equals, and then we move the decimal point along 2 points, or more to the point, the numbers are moving 2 to the left. So that gives us 34.5454545, etc. Now what you'll see is that the curring element is now lined up. So if we call this equation 1 and we call this equation 2, if we do equation 2 and take away equation 1, so the bottom one take away the top one, you'll see that we get 99x equals 34.2, because it's the 34 take away 0 and the 5 take away the 3. Now, we could divide through by 99 at this point, but I think it's a bit untidy to have a decimal amongst a fraction. So I think it's quite nice just to choose to multiply by 10 at this point, just so that we get we lose the decimal. So at that point, we're going to get 990x equals 342. And then if we divide by 990, we get x equaling 342 over 990. And then we just got to simplify this down. Now, I think at this point I've attempted to cheat. We know the 990's got to go to 55. So do 990 divided by 55 in the calculator, and you see you get 18. So to simplify this all in one go, let's choose to divide top and bottom by 18. And we get 19 over 55, which is what we had to show. So that's topic 1 that I wanted to cover. Turning a recurring decimal into a fraction. Okay, now topic number 2 I wanted to look at is bounds. Okay, and this is a typical bounds question. So we're given this when we're given A, B, and C, and we've got to work out the lower bound for the value of y. We've got to work out the lower bound for the value of y. So how do we make y as small as possible? Well, given we've got a fraction, we're going to want the numerator, the top bit, to be as small as possible. So a is going to be the lower bound. Now, to make a fraction as small as possible overall, you want the numerator to be as small as possible and the denominator to be as big as possible. So how do we make this denominator as big as possible? Well, we're going to need to have the upper bound of b and then take away the lower bound of c. That's how we maximize the number on the bottom, by taking the bigger number and take away the smallest number. So overall, when we do this, we're going to get the smallest possible a on top and the largest possible b minus c on the bottom. And that comes about by having an upper bound for b, take away a lower bound for c. So let's just substitute in. So 2 times the lower bound of a. Well, a is 42 correct to 2 sig figs, so that's going to be the lowest number that can be. It's going to be 41.5. That would round up to 42. And then on the bottom, we need the upper bound of b. Now, the upper bound for b is just a fraction below 24.5. It's going to be 24.49 recurring, but for the purposes of these bounds questions, we just keep the symmetry really. So we're going up and down by 0.5. So I know this really should be 24.49 recurring, but really we're fine using. In fact, I'll expect you to use 24.5. So that's the upper bound for B, and then we're going to take away the lower bound for C. So what's the smallest number C can be that would round to 14? Well, that's going to be 13.5. Okay, lower bound, upper bound, lower bound. So popping this all into your calculator, and I would suggest you use that fractions button, the 1 3 down, this one here, the 1 3 down on the left, this button here. Okay, just makes it nice and easy. So in the numerator, we're going to have 2 times 41.5. Use the blue circle to move down to the denominator. 24.5. Take away 13.5, and that gives us 7.54. 7.54 with the. I'm just trying to see, is that I can't quite see in the start. Yes, I think that's got a dot on the 5 and a dot on the 4. So to two significant figures, that's going to be 7.5. Okay, so we've covered recurring decimals to fractions, we've recovered bounds. I now want to have a quick look at the third topic, which I think is quite likely to come up, which is completing the square. So, how do we complete the square? So we've got this question here, x squared plus 6x minus 7, and we've got to pop this into this completing the square format. Now the key bit is your opening position, is to know what to pop in here. Okay, now to what we pop in here, we halve the coefficient of the x. So given this is +6, we put +3. Had this been +8, we would have said +4. Had it been -8, we would have said -4. So the big learning point is to make sure that this number here is half your coefficient of x. Now you can probably do this in your head, but if you imagine what x plus 3 all squared is x plus 3 times x plus 3, which is x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. So as things stand, if we just leave it as x plus 3 all squared, we're going to get x squared plus 6x plus 9. But for now, all I want to get is x squared plus 6x. So I need to take away 9. And now that component there is equal to this x squared plus 6x. Because x plus 3 all squared is x squared plus 6x plus 9. And if we then take away 9, we're just left with x squared plus 6x. And then, so that replaces that. And then we mustn't forget the -7. So just tidying up this, we've then got x plus 3 all squared, -9 minus 7 is -16. So we've now got this into this format. Okay, so A is +3 and B is -16. So that's completing the square. So that's 3 topics down. The next one I want to look at is proportion. So direct proportion firstly, and then indirect proportion secondly. So here's a typical direct proportion question. P is directly proportional to r cubed. So, and then we've got a couple of values, then we've got to find a formula for P in terms of r. So your starting point is to say P equals K, some unknown constant, times r cubed. And this is like a provisional formula, if you like, our starting point. So because we are directly proportional, it's going to be K multiplied by something. And then for the second component, we just follow the instructions. So had it said P is directly proportional to the square root of r, we would be saying P equals K times the square root of r. So at that point, well, that's step 1. That's our provisional formula. And now we've got to find K. So we can find K by substituting in these 2 values that we've been given. So P is 343, and that equals K times R, which is 3.5 cubed. So K is going to be 343 divided by 3.5 cubed. Okay, just dividing both sides by 3.5 cubed. So 343 divided by 3.5 cubed equals 8. So we can then have a final formula, find a formula for P in terms of R. So P equals, but our unknown constant is no longer unknown, it's now 8. So it's 8 R cubed. Okay, so that's how we do, that's how we would answer one if it's direct proportion. Now, I think it'd be quite nice to look at an inverse proportion question as well. So here's one where P is inversely proportional. So P is inversely proportional to the square of D. So our provisional formula is going to be P equals K divided by the square of D. So that is our starting point. So in the previous question, when it said P is directly proportional, it was K times something, but this is inversely proportional, so this is K divided by something, K divided by the square of D. Now step 2 is the same idea. They're going to provide you with a couple of values to allow you to work out the constant K. So 25.6 equals K over an 8th squared. So multiplying both sides by an 8th squared, K equals 25.6 multiplied by an 8th squared. So K equals 0.4. So our final formula is going to be P equals 0.4, K 0.4 divided by D squared. Right, now the next topic I wanted to look at is on sequences. Now I think this is bound to crop up because this is the new topic that's been brought into the IGCSE. So remember, we're given this formula and the formula sheet at the front of the paper. This allows us to work out the sum of a number of terms in an arithmetic series. So, remember that's given, so that's why I've included that over here. Now we're told our first statement is the third term of an arithmetic series A is 19. Now let's just sort of go back a step. How do arithmetic series work? Let's just go into a nice simple one. Let's say 5, 7, 9, 11, 13, etc., where we're going up in twos, and our first term is 5. So let's just start getting used to the lettering. A is the first term in the series, so that would be 5. D is the common difference, how much you're going up in, and in this scenario, this would be 2. Now let's just go and use our A's and D's, just to look at the series in more general terms. This is the first term, that's A. Okay, so that's for the first term. Remember, n is the position of the term in the series. So that's when n is 1, that's when n is 2, that's when n is 3, that's fourth in the sequence, that's fifth in the sequence. So how do we work out the second number? We take our first one and we add on our common difference. So that would be A plus D. How would we work out the next one? Well, we would add on another D. So that would be A plus D plus D, or in other words, A plus 2D, then A plus 3D, and so on. Now, what I want you to pick up is the fact that the number that n is one more than the number of D's, or perhaps better looked at the other way, that if you're fifth in the sequence, that is when it's A plus 4D. Now, we're told the third term of a series is 19. Now that is when it's A plus 2D. The third term is A plus 2D. So from that sentence at the top, we can create an equation, A plus 2D equals 19, because it is the third term in the series. Now, so that's equation 1. Let's just bank that for now. Now our second sentence allows us to create another equation. Now, this is to do with the sum of the first 10 terms, So for this, we're going to be using this formula over here. So we're saying the sum of the first 10 terms is 290, and that equals n, well, that's the number of terms in the that we're summing, so that's going to be 10 over 2, and then 2 lots of our unknown A, plus 10 minus 1, so 9 lots of D. Okay, so 290 equals 10 over 2, which is 5, 2A plus 9D. Now you can either multiply out by 5, or I'm going to choose to divide both sides by 5. So 290 divided by 5 gives me 58. So 58 equals 2A plus 9D. Now that really is my second equation. Now can you see I've created a simultaneous equation here. I've got A plus 2D is 19, and 2A plus 9D equals 58. Just turning it around the other way around. That's my second equation. So I've now just got a simultaneous equation to solve, just like solving. So we get 2A plus 4D equals 38. Now compare that to our second equation of 2A plus 9D equals 58. Now if I take away one from the other, that will eliminate the A's, giving me 5D equals 20, so D equals 4. Now I know, can you see that? I think it's just fitting on. Okay, I know that, hi JJ, I know that D is 4, and if I go back to this equation here, I've got A plus 2D equals 19. JJ, would you do me a favour? Can you just confirm that the sound's working? That would be great. Thank you. So A plus 2D equals 19. So if I go and substitute 4 to this equation, we've got A plus 2 lots of 4 equals 19. So A plus 8 equals 19. So A equals 11. So I know that A is 11 and D is 4. Thanks, Jonathan. Thanks. Right. Okay. So A is 11, D is 4. So we can now actually answer the question. The question says find the 10th term of a series. Now the 10th term, the actual position, that would be n is 10. So the actual equation for the 10th term is going to be A plus 9D. A plus 9D. So that's going to be my A, which is 11, plus 9 lots of my D, which is 4. So 11 plus 4 nines are 36, gives me 47 as a final answer. Okay, so so not easy, and you know that, and this is the hardest question in the paper, so you wouldn't expect it to be easy, but it's not impossible. So the key bits to take on board: one is that you are given the sum formula in the formulas at the front. And the second one, which you're not given, is to appreciate that if you're 5th in position, that when n is 5, then that term is A plus 4D. If you're 10th in the sequence, then that specific term will be A plus 9D. So wherever you are in the sequence, the number of D's is 1 less than that. So that was the 5th topic I wanted to have a look at. That's tricky. The 6th one that I'm sure will come up is plotting a quadratic graph. So here we go. Let's have a look at this quadratic graph. So do look out for the symmetry. We know a quadratic graph, given it's a plus x squared, is going to be a positive parabola, a smiley face. So just look out for the symmetry in your y values. Now, at the moment, we haven't got any repeated values. We haven't got any symmetry, but that will come. So start off by working out a nice easy one. How about when x is 1? So when x is 1, y is going to equal 1 squared, which is 1. Take away 4 lots of 1, which is 4, and add 2. That is minus 1. Now I have now got my symmetry. Okay, minus 1 to minus 1. So sort of pop down a little loop there and think of that like a ripple in the pool. Okay, you drop the pebble in there, and then we're now rippling out our results. So that minus 1 matches with that minus 1. That 2 is going to ripple around to there, and whatever value I get for 5 is going to ripple around to minus 1. Okay, I mean, I could prove that this is 2, and 4 squared is 16. 16 take away 16 is nothing. Nothing add 2 is 2. But if you can just rely on the symmetry, it just speeds things up, and you don't run the risk of making a mistake with your calculations. Now, what about when x is 5? So we're going to have 5 squared, which is 25. Take away 5 lots of 4, which is 20. And then we're going to be adding on the 2. So that's 5 add 2, which is 7. So that's also going to ripple around to being plus 7 over here. So plotting those points, we have minus 1, 7, 0, 2, 1 minus 1, 2 minus 2, 3 minus 1, 4, 2, and 5, 7. Okay, and then put in a nice gentle curve. Make sure you use a pencil. Make sure it just curves around at the bottom. Don't give it a flat bottom. It's not a vase. Whoops, that's not good. And there we go. Do like that. So that's our answer. No, it isn't. We've got to then carry that on up to there. So it is a symmetrical positive parabola. So that was topic number 6. I now want to look at simultaneous equations. Well, if you were following that arithmetic series a few minutes ago, we've effectively done one of these already, but I'll do it again anyway, just so we can have the 2 simultaneous equations back to back. So When you've got one like this, we've only got x, y's, and numbers. There's no squares. It's not a circle. It's not a quadratic graph. These are both straight line graphs. It's just where two straight lines cross, x's, y's, and numbers. So the best way to solve these is by elimination. So you're going to want to either line up the x's or line up the y's. Now, I think the x is as good as any. So let's call this equation 1 and that equation 2. Now, I need to have the same number of x's in both. So I'm going to choose to take my first equation and times it by 5 to generate 10 x's. And then I will take my second equation and times that by 2 to generate 10 x's. And then those 10 x's can be eliminated. So let's take this first equation and times everything that moves by 5. Each of the three terms has to be times by 5 to keep it all equal. So 2x times 5 is 10x. 7y times 5 is plus 35y. 31 times 5, I'm pretty sure that's 155, but let's just check, is 155. Now let's take our second equation and double everything. So 10x minus 6y equals 32. Now just take your time at this point. We need to eliminate the x's. Clearly, if I add these two equations together, I'm going to get 20x. The x's won't be eliminated. So in order for these x's to cancel, I've got to take away equation 2 from equation 1. So 10x take away 10x is nothing. That's the whole point. Now 35y take away minus 6y. Well, we're minusing a minus, so that's a plus. So that's 35y, add 6y, which is 41y. And 155 and 32 is 187. So to make y the subject, divide both sides by 41. So 187 divided by 41. Oh, that doesn't look right. I think I've gone wrong there. Let me have a look. That just doesn't look right. I've gone wrong there. Where have I gone wrong? Let's times up by 5. 31 times 5. 155. Oh, I'm taking away, sorry. That's silly me. 155 take away 32, not adding like I've done. 155 take away 32 is 123. 123 divided by 41 gives me 3, I think. Yeah, 3. So y equals 3. Now, you then go back and take, to work out the x value, you've really got to start again. So go back and take either of the equations. I'm going to take the top equation. So 2x plus 7y equals 31. And substitute in what you just found out. You just found out that y is 3. So y is 3. 7 3s are 21. So 2x plus 21 equals 31. Take away 21 from both sides. 2x equals 10. Divide by 2. X equals 5. So x equals 5 when y equals 3. So we haven't had one of those linear simultaneous equations yet. Equally, we haven't had one of these quadratic simultaneous equations yet. Now, this has to be approached a different way. You really have to solve this by way of substitution, okay? You do not try and line anything up and eliminate them by adding or taking. That's just not going to work because we've got squares cropping up. Now, it may be that you've got squares in both the x's and the y's, like here. This second equation is a circle. Or you may have y equals x squared, blah, 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 which is just a quadratic graph. But either way, the second you've got x squareds or y squareds cropping up, you need to change tactic and solve it by way of substitution. So how do you do that? Well, step 1, take your linear equation and rearrange it to make either x or y the subject. Now, clearly, y is already on its own, so it makes sense for us just to take away 2x from both sides here. So we get y equals 3, take away 2x. Now, we then take this and we substitute this into the non-linear equation. So we've got x squared plus y squared equals 18, but we're going to replace the y with 3 minus 2x. So it's not going to be y squared, it's going to be 3 minus 2x all squared. So x squared plus 3 minus 2x all squared equals 18. Well, you now just number crunch. So remember, 3 minus 2x all squared is 3 minus 2x multiplied by 3 minus 2x. Claw, 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 claw. So you get 9 minus 6x plus 4x squared. Gathering up those middle terms, you get 9 minus 12x plus 4x squared. So we've got our x squared here, but our 3 minus 2x all squared is this. So that's plus 9 minus 12 plus 4x squared, and that equals 18. So gather up your like terms on the left-hand side. So we've got 5x squared minus, sorry, that should be 12x, that shouldn't be. So 5x squared minus 12x plus 9 equals 18. Now, this is going to be a simultaneous equation we're going to have to solve. So set this equal to 0. So take away 18 from both sides. So 5x squared minus 12 minus 9 equals 0. Okay, so this will factorize. So I think I'm going to factorize it. But you could, of course, at this point, just decide to use a quadratic formula and just go and say A equals 5, B equals minus 12, and C equals minus 9, and substitute it into the formula. That would be absolutely fine. But I'm actually going to factorize this. So I'm looking for two magic numbers that multiply to be the 5 times the minus 9, which is minus 45, but at the same time add to be minus 12, which is 3 and minus 15. So 5x squared minus 15x plus 3x minus 9 equals 0. Factorize the first two terms, 5x, x minus 3 plus 3, x minus 3. So 5x plus 3, x minus 3 equals 0. So our two solutions for x are minus 3/5 and plus 3. So that's going to be our two x values, and then our y values comprises 3 minus 2 lots of whatever x is. So the y value here is going to be 3 minus 2 lots of minus 3/5, and for here y is going to be 3 minus 2 lots of 3. So here we've got y equals 3 minus, so that's going to be plus 6/5. So 3 plus 6/5 is 4 1/5. And over here, 3 minus 6 is minus 3. So our solutions are going to be x equals minus 3/5, y equals 4/5, and x equals 3, y equals minus 3. Okay, so let's just summarize that again. This is harder. Again, this was a last question on this paper. So you, the key starting point is to appreciate there's a different strategy. Here we've got a non-linear equation, so we need to substitute the linear into the non-linear. So make either x or y the subject and substitute into the non-linear, and then just number crunch away, getting a quadratic, which you can either factorize or you could use the quadratic formula. Once you've worked out your x values, substitute back into the simpler one to work out your y values. Okay, so we've got about 4 more topics to go, I think. So the next one I want to have a quick look at is the calculus. Hi, Ebs, all right? So, so for the calculus, we're going to have to differentiate this. Now, remember how we differentiate. For each term, you multiply by the current power, and then secondly, reduce the power by 1. So dy dx, we're going to be 3 times 2. So our dy dx is going to be 6x. That's multiplying by the current power, and then reducing the power by 1. So we get 6x squared. Same with the second term, multiplied by the current power. So 2 times the minus 9, which is minus 18x, and reduce the power by 1. So x squared becomes x to the power of 1, which is just x. Now, that's it, because the plus 7 when you differentiate disappears. So we're told for part B, the point P lies on the curve, the gradient at P of the curve is minus 27/2. Find the coordinates of P showing working. So got to be careful you get this the right way around. This is this allows you to work out the gradient at any value for x. Now in this situation, we've actually been given the gradient that we need to get, and we've got to work out what x value gives us this gradient. So for this, our starting point is to say we take our differential and set that equal to minus 27/2. Okay, had the question said find the gradient when x was 3, say, you would just substitute 3 into the differential, but this is the other way around. This is we're given the gradient, find the x value. So let's turn this into a quadratic. So let's add 27/2 to both sides. So 6x squared minus 18x, add 27/2 equals 0. Now I don't like having this fraction here, so I'm going to choose to multiply it throughout by 2. So 12x squared minus 36x plus 27 equals 0. Now that has got a factor of 3, so let's divide by 3. So 4x squared minus 12x plus 9 equals 0. And does that, yes, that will factorize. So we're two magic numbers that multiply to be 36, add to be minus 12. So that's minus 6 and minus 6. So 4x squared minus 6x minus 6x plus 9 equals 0. Fully factorize the first two terms, so 2x minus 3, and then minus 3, 2x minus 3. So we've actually got 2x minus 3, 2x minus 3 equals 0. So our value for x as a repeated solution is going to be 3/2. Now that is the x coordinate. And then just be ever so careful. Don't be tempted to go and substitute that back into the differential. To find the y value on the curve, you've got to substitute this back into the curve itself. So our y value is going to be 2 lots of 3/2 cubed minus 9 lots of 3/2 squared plus 7. So you would work that out, and that would be your y value. I think for time purposes, I think I'm going to skip doing that, okay? But you just work that out on your calculator, and that would be your y value. Okay, so 3 topics to go. I want to look at a couple of angles topics and then finish off with histograms. So firstly, I wanted to have a quick look at angles with parallel lines. I don't think this came up at all in the first paper. So let's actually answer this question and then just remind ourselves of the other bits and pieces of angles and parallel lines. So show that angle ABF is 70 degrees. So we've got to show that that angle there is 70 degrees. Okay, so first things first, we can say that that angle there is 35 degrees because vertically opposite angles are equal. Give a reason for each state of your working. So let's go and say angle AFB equals 35 degrees because vertically, you must now use that word, vertically opposite angles are equal. Now we've got a parallelogram here, and opposite angles in a parallelogram are equal. So we can say that that angle there is 75 degrees and say why. So we can then say angle BAF equals 75 degrees because opposite angles in a parallelogram are equal. And then obviously once we know that's 75 and that's 35, that must be 70 because angles in a triangle add up to 180. So finally we can conclude angle ABF equals 70 degrees because angles in a triangle total 180 degrees. Now just while I'm here, let's just remind ourselves of the other angle formulae. Okay, say we needed to work out what this angle was here. that is coming about by way of a Z angle. Okay, that angle there is equal to that angle there, sort of the Z angle rule. Okay, that angle there equals that angle there, but don't say Z angles, say alternate angles are equal. Let's say you needed to work out that angle there. That would have been 75 degrees, and that's the F angle rule, where we're saying these two angles are equal. Okay, that would be the same as that. It's like an upside down F, but again, don't say F angle rule, just say that corresponding angles are equal. So Z angle, alternate angles are equal, F angle, corresponding angles are equal. Okay, 2 to go. So the next one I wanted to address was just to remind you about interior and exterior angles. Okay, so here's a classic question. Each interior angle of a regular polygon is 156 degrees. Now remember, if you've got a shape, okay, the interior angle is that angle there. That is the exterior angle. And by definition, because they form a straight line, they must add up to 180 degrees. So for this question here, we can say because the interior angle is 156, our first line of working, we can say the exterior angle equals 180, take away 156, which is 24 degrees. Now, the second rule, so first rule, an interior plus exterior add up to 180. Our second rule is that the exterior angles total 360. Okay, exterior angles total 360 degrees. Now, if each of them is 24 degrees and they total 360, how many exterior angles have we got? Well, we've got to do 360 divided by 24. So 360 divided by 24 equals 15. So there are 15 exterior angles, so there are 15 sides. Okay, so the two rules, interior plus exterior equals 180, and exterior angles total 360 degrees. Right, finally, the final topic I wanted to look at, so topic 12, are histograms. Okay, now I think people overcomplicate these. All right, just a couple of things to remember, and then it's just common sense. Now, the key learning point is that the frequency is the area of each of the bars. Okay, so each of the rectangular bars we're going to draw in here, the area is going to be these frequencies. And we're just going to have a series of rectangles here, with these being the areas of each of them. So let's consider the bases of these rectangles. Now, the bases of these rectangles is going to go along here. That's the distance. And here we've got the base of all the rectangles. So let's think of this as the base of the rectangles. So this first rectangle is going to go from 0 to 10. So that's got a base of 10. The next one from 10 to 25, which is 15. 25 to 45 is 20. And 45 to 60, which is 15. So they are the bases. Now think about a rectangle. We have base times height equals area. So working backwards, area divided by base must give us the height of each of these rectangles, or in other words, the frequency density. So if we take these areas here and divide them by these, this would give us our various heights. So we're going to do 33 divided by 10, which is 3.3. 39 divided by 15, which is 0.6. 36 divided by 20 is 1.8. And 12 divided by 15, which is 0.8. So these are going to be our various heights of the rectangles. Now choose a sensible scale. So I think every 10 squares is there. So we need to go up to 3.3. So let's make that 4. So let's make that 1.0, 2.0, 3.0, and 4.0. And then just complete the rectangles. Now I'm going to, you should use a pencil and a ruler. I'm not going to. All right, so my first rectangle is going to have a base of 10 and a height of 3.3. So that's going to go to there. Okay, so a base of 10, a height of 3.3, base times height gives us an area of 33. Similarly, from here, our second rectangle is going to go from 10 all the way up to 25, which is a base of 15, and that's going to go to a height of 0.6. Right, that's a height of 0.6. 15 times 0.6 gives us our 39. And that's not right, is it? There's no way 39 divided by 15 is 0.6, sorry. 39 divided by 15 is 2.6. Stupid. Sorry. So that's got to be a height of 2.6. Forget that. Okay. So it's going to be a height of 2.6. So we're going up to 2, 2.5, 2.6. There we go. Okay. So we've got a base of 15, a height of 2.6. Base times height gives us our area of 39. Then our third one, okay, we've got a base going from 25 to 45, 25 to 45, a height of 1.8. So that's there. Again, you would use a ruler and a pencil. That gives us an area of 36. And finally, our final bar goes from 45 to 60 and has a height of 0.8. And that gives us that bar there. Okay, so key bit is simply just doing, is remembering that the frequency is the areas. Any rectangle, it's just base times height equals area. So area divided by base gives us your height. Now for part B, one of these people is to be selected at random. Find an estimate for the probability that this person traveled more than 30 kilometers to get to the airport. So more than 30 kilometers. So there's our 30 kilometers. Now, can you see that this, if we sort of think of dividing this into 4 strips, that we want to have all of this area here. That's going to be more than 30. Now, this, the bit we want of this bar here, more than 30, is 3 strips out of 4 strips. So we want 3/4 of this 36, which is 27. The area of those 3 strips there is 27. So we want 27 here plus the 12 here, giving us 39. So that's 39 of the 120 people. All right, find an estimate for the probability that this person traveled more than 30 kilometers to get to the airport. So it's going to be 39 out of the 120. And remember, always give your probabilities as a fraction if you've got the choice. It's so much easier. Okay, that's it. Those were the 12 questions I wanted to go through. Good luck with your exam next week.